going to go ahead and learn how to make our very own ERC20 token in this video. So there could be a whole bunch of different reasons why you want to make an ERC20 token. Maybe you're just experimenting and learning, doing it for fun. Maybe you thought of some sort of new use case for utility token, or you want to make a meme coin, whatever the case is. Your starting point pretty much certainly will be leveraging these OpenZeppelin ERC20 contracts, as they make the process of creating your own token very streamlined and also add a lot of security features underneath the hood as well. So we're not going to do a whole lot of customization in this example. Depending on your use case, you might need to do more or less. But what we're going to do here today is just make a token called mock token, and we're going to give it some access control, giving a special permission to the address that can mint and burn tokens. And we're also going to add pausability to allow a pauser address to go ahead and pause and resume transfers as well. So let's go ahead and begin. We have these three contracts already imported from the OpenZeppelin library. Let's go ahead and name our contract mock token. And then we can go ahead and extend ERC20, access control, and pausable. So we need to create a constructor here and pass in some required parameters and do a little bit of setup here. So for the ERC20, let's just go one by one here. So for ERC20, I think we just need a symbol and name pretty much. Let's go ahead and check it out. So yeah, we need to pass in a name and then a symbol. So we're going to go ahead and call this, once again, mock token. And let's go ahead and make the symbol like, I guess, MTK or something like that. And then for access control and pausable, there really aren't any constructor parameters we need to pass, but we do need to do a little bit of setup though. So let's actually go ahead and declare our roles right here. So we have, let's see here, string, constant, or public, constant. Actually, I'm sorry, it should be not string, it should be bytes, 32. And we want to make our minter role. And then we're also going to go ahead and make a pauser. So let's just copy this down to the next line here. And then we're going to go ahead and grant the permissions in the constructor. So what we want to do here is first set the default admin to be the deployer of the contract. So we're going to say underscore grant role. Then the default admin role constant is already included in the access control contract here. And then we're going to say message.sender. Then we also want to set up our other roles here as well. So let's go ahead and do that right now. So let's put the minter here, and then we also have the pauser. Now we don't want message.sender to be privileged with all three of these roles. That would kind of defeat the point of the granular access control. So what we're going to do here is actually add a minter parameter as well as a pauser parameter. And then those addresses will be the ones assigned to have those privileges. But typically it's considered to be good practice to do some sanity checks at the beginning of the constructor here to validate the input. So make sure nothing weird happens and the zero address doesn't get passed in as one of these values here. So we can actually define a custom error for that. We're going to say error invalid zero address. And then if either one of those addresses passed to the constructor here is equal to the zero address, we're just going to revert the transaction. So we'll say if minter equals address 0. We'll revert with the custom error and do the same thing for the pauser as well. The other thing is, with the access control library, like if you or when you, I should say, set the roles, there is an event emitted here. Let's go to the interface. So whenever you set a role, then it'll emit this role granted, event, and same thing when a role is revoked. But if we want to allow off-chain sources to be able to see who the minter and pauser and admins are, we would probably need to define some state variables for that. And actually, to save gas, I think it's better to put these as private since no one needs to really read these. So let's change these to private. And then we're going to have address public admin. And then the same thing for the minter and pauser. There's actually an extension for access control where you can have an enumerable version where someone could call a function and pass in which role they want to check to see which addresses have that privilege, and then that's another way that you could read off chain who has which role. But we're using the standard version, so we have to we want to allow off chain readability for these addresses. We need to put these state variables here. So let's go ahead and assign those down at the bottom of the constructor. So admin equals message.sender. But now that the constructor is pretty much set up here, let's go ahead and dive just a little bit deeper into what's already included in this OpenZeppelin ERC20 contract. So there's not much we have to do in terms of configuring things. Once you pass in the name and the symbol, then they already provided these getters here for that. There's also a function for decimals. That the default is basically 18, which is a standard for most tokens. If you're making a stable coin, maybe you want to set this to 6 decimals, but we're going to leave it at 18 for our use case here. But the interesting thing is these 3 functions are actually part of the ERC20 standard. So that's why you're going to see this ERC20 metadata interface being extended here, because when you use the OpenZeppelin version of the ERC20 implementation, they're basically forcing you to include these 3 functions that aren't actually required as part of the ERC20 standard. So in any case, we have our primary functions here, the ones that are visible publicly, which would be getting the total supply, the balance of any given address, being able to transfer tokens, checking the allowance, approving another address to spend tokens on what the caller's behalf, transferring from once this approve is set, then whoever is approved to spend tokens on another address's behalf can call this function to initiate that transfer. These are all the internal functions down below. So one thing to notice is that when you're minting tokens, what's happening underneath the hood is that it's actually calling this update function with the 0 address as the address that you're sending tokens from. So that way it's basically indicating that these tokens are just being created at that point in time. And the reverse is true for the burn in the sense that tokens are being sent to the 0 address and therefore making them inaccessible. So that's how you burn tokens, by sending them to the 0 address. So what we need to set up is pretty much just a way to mint and burn tokens. If you can't mint and burn tokens, then there's really no point to having a token in the first place. So let's go back to our implementation here, and we're going to just put a wrapper around these mint and burn functions. And then we're going to make sure that only the minter can call them. So function mint. And then we're going to make this external, but we're going to say only role minter. And I guess we probably need to say how many we're going to mint, right? So let's put a uint here, and we're going to call this amount. So I guess, yeah, sorry, I forgot. Also, we need to say who we're minting them to, so we're going to put that as a parameter as well. Let me just go ahead and actually reverse these so it kind of matches the way we're propagating them down to the So do account and mount. You know what? Let's be generous with ourselves too. Probably in the constructor, we want to start off with some default tokens, right? So let's make a constant here called initial supply. And we'll make this public constant so anyone can see what the initial supply would be. So we'll be generous with ourselves, give ourselves here like 1 million tokens. That's going to be 1 million times 10 to the 18th. Okay, and then at the very bottom of all this, let's just call the main function here. We're going to put the message.sender as receiver. And then we'll put initial supply. All right, so now we have our initial supply. We have our mint function, which is only accessible to the minter. And then likewise, the minter should be able to burn tokens. So let's go ahead and copy all that down. Put a wrapper around the burn function. In this case, we just need to say, I believe, how much we're going to burn. Oh, I guess we're saying which count we're burning it from. So yeah, let's make that a parameter action. I'm second with that. Let's look a little more closely at this burn function under the hood here. See what's happening. So it's already checking to make sure that we're not burning them from the 0 address, as it wouldn't make sense since that's where they're actually going to end up going. Then update function. If it's to the 0 address, then it already takes care of the total supply for us, making sure that the accounting in that sense is already updated. But it's not checking whether or not there's sufficient balance from that address in the first place for some reason. So probably that's something we're going to want to handle ourselves here to make sure we're not burning more tokens from the address than they actually have. So let's see here. Actually, no, I'm sorry, it is happening here. So obviously, if you're burning tokens, they're not coming from the 0 address, so it's going to, execute this else block here, and that's going to check to make sure that they have enough balance. So never mind. Of course, OpenZeppelin already took care of that for us. So let's go back to our contract. So we have the wrapper functions for mint and burn. We also want to make sure that we override the transfer and transfer from functions to make sure that people can execute transfers when the contract is paused. Just need to go ahead and declare the parameters here. So basically, we have an address, who the tokens are being transferred to, as well as the amount that is being transferred. And then we're going to put our when not paused modifier, and we're actually going to be overriding the default implementation, and therefore we have to return the boolean. Same thing here. But all we're really going to do here is just call the super and propagate down the parameters. So let's see what's it complaining about here. So visibility is different. Let's go ahead and see what it should be. Oh, it should be public. Okay. All right, that takes care of that. See, got a warning there. Just wondering if that's worth investigating. Oh, whatever. We'll just leave that as for now. Then we're just going to copy the same thing down for the transfer from. And then I believe we also need a spender parameter here. Let's see here, where is the transfer from? Oh yeah, from and to basically. Okay, so that way we were able to just kind of put a wrapper around these, add our own modifier to make sure that no one can execute transfers when the contract is paused. But then at the same time, we're guaranteeing that whatever logic was happening in the original implementation is still going to happen by calling the super here. Let's see, is there anything I'm missing? So that might just about do it. This is a pretty basic implementation here. So we just have the bare minimum, which is the ability to mint and burn tokens. And also we were making sure that, in our implementation that, we had the ability to pause the contract and prevent transfers from taking place if needed. So let's go ahead and just jump over to the unit tests that I prepared ahead of time here. So we're just testing to make sure the roles were set correctly, to make sure that the permissions are working properly so only the minter can mint and burn or tokens, and also to make sure that transfers can't take place when the contract is paused. I just realized though I didn't add the script yet to the package.json, so let's go ahead and make our script here. Call it test ERC20. Then we're gonna test the unit, the file here. Let's see what's it called, mock token. Okay, so mock token.js. All right, let's see what happens here. Something didn't work right, so it's not finding the contract. Oh, let's see here. Yeah, oops, it should be token. All right, one more time. All right. Oh, of course. So, I forgot something. We forgot to put a wrapper around our pause functions to make sure only the pauser can call those. So that will be important. So let's go ahead and make a couple more functions here. We're going to say only roll pauser. If you haven't seen the video already on the pausable contract, I'll put a link below for that one as well. But all we're doing here is just calling that pause function we have internally here. Unpause. All right, let's see if there's any more errors we need to fix though. Seems like they were all related to the pause functionality. Oh, the address 0, let's see. So, should emit a transfer event when tokens are minted. Okay. Oh yeah, they don't no longer have the constants namespace here. They just put everything underneath, under the just default namespace of Ethers. So let's make sure that auto completes. Yeah, 0 address right there. Okay, so let's try running these tests one more time. Okay, and they all passed. So there you have it, the basic implementation of an ERC20 token using OpenZeppelin's contracts. There's all kinds of customizations you can add, and there's other OpenZeppelin contracts you could leverage, like the meta transactions, in case you want to include the ability for addresses to make transfers and have the forwarder pay the gas on their behalf, for example, and so forth. But if you're just trying to make a meme coin, then what you learned in this video will comprise the vast majority of what you need to go ahead and get started with that. So just as usual, I'd encourage you to go ahead and try these unit tests on your own and play around with them, add your own tests as well. But that's it for this one. Code is in the link below, and hope to see you guys in the next one.